Dow Corning knows that fire safety is a prime concern when selecting a new transformer or retrofilling an existing one. It's been demonstrated that all transformers, including dry and cast resin transformers, burn under certain conditions. Liquid-filled transformers offer numerous advantages unavailable with other transformer types. Advantages that include proven performance, a compact structure, high efficiency, high basic impulse level, a reasonable price, long service life, sealed construction, ideal for harsh environments, no special housing requirements, and low maintenance costs. However, silicone-filled transformers provide the proven performance of liquids, plus the outstanding environmental and fire safety benefits unique to silicones. A series of fire tests were performed at Underwriters Laboratories in 1987 to measure the burn characteristics of Dow Corning 561 Silicone Transformer Liquid. The tests were also performed on other liquid transformer materials, including high molecular weight hydrocarbon. In the product size calorimeter tests, a pan filled with transformer fluid was placed beneath the calorimeter hood. A propane burner was used to ignite the samples. The energy provided by the burner was far less than that available from faults and fires in transformer rooms. During each test, the fluid samples ignited within 1 minute of burner application. In the past few years, heat release rate has become increasingly recognized as the most relevant measure of fire hazard. The Federal Aviation Agency now measures heat release rate in tests conducted on aircraft cabin furnishings. Underwriters Laboratories conducts similar tests on furniture, and Factory Mutual on transformers. In the product size calorimeter tests, heat release was measured for the silicone liquid on the left and high molecular weight hydrocarbon on the right. Around 2 minutes into the test, with the ignition burner still on, the silicone liquid reached its peak heat release rate, 394 kilowatts. But the high molecular weight hydrocarbon still had a long way to go to hit its maximum. Underwriters Laboratories' report of the tests indicates that white smoke developed while the silicone liquid burned. The report also mentions that a white crust, a silica ash, was beginning to form on the surface of the silicone when the test was terminated. In previous tests at other independent labs, this ash slowed the burning rate of the liquid and eventually extinguished the fire. Initially, the high molecular weight hydrocarbon developed white smoke, which was then replaced with heavy black smoke. Within minutes, the dense black smoke filled the test room so completely that observation was difficult. Following the removal of the ignition burner, the heat release rate of the silicone liquid dropped to 7, while that of the hydrocarbon reached 730. The silicone's temperature, measured 8 feet above the burn pan, also fell to 127, while the temperature of the high molecular weight hydrocarbon reached 245. At 3 minutes 30 seconds, the heat release rate for the silicone liquid was 4, and the hydrocarbons was 1,069. Temperature of the silicone crept downward, while the hydrocarbon continued to move up. UL's report also mentions that the maximum flame height for the silicone was 10 inches, while the high molecular weight hydrocarbon generated 8 to 10-foot flames. The temperature for the silicone liquid stabilized at about 100, while the high molecular weight hydrocarbon continued to escalate to over 1,000. The heat release rate for the high molecular weight hydrocarbon continued to climb as well, reaching a high of 1,839 kilowatts at 12.5 minutes. In these tests, the high molecular weight hydrocarbon produced 3.5 times more smoke than the silicone liquid, as measured by the light obscuration method, 5 times more carbon monoxide and 10 times as much heat. The silicone liquid's heat release rate remained nearly constant after the first few minutes, reaching a high of 58 kilowatts per square meter at 14 minutes. At 14 minutes, the high molecular weight hydrocarbon was recorded at 1,643. To investigate the relationship between the product size calorimeter tests and actual fires, full-scale pool fire tests were also performed by UL, using representative fluids and a 750 kVA transformer tank. This check was considered necessary because most materials burn faster and more intensely in larger fires. This is because the heat given off by a large fire feeds back to the material being burned. This feedback, also called flux, increases the rate at which most materials break down into burnable volatiles, more fuel for the fire. The full-scale UL tests confirm that the silicone liquid, unlike most other materials, breaks down very slowly with increased flux. The heat release and temperature data gathered by underwriters' laboratories during both sets of tests are very similar to those garnered when similar tests were run by Factory Mutual Research Corporation and Southwest Research Institute. With the increased understanding of the role of heat release as a critical measure of fire hazard, plus the data from the UL tests, the conclusion is obvious. Dow Corning 561 Silicone Transformer Liquid is your best choice for proven performance and for fire safety. For detailed data concerning these tests and 561 transformer fluid, contact your Dow Corning sales representative. Dow Corning 561, the safe solution.